Hi, this is Angus at LabVac, and today up on the bench I have an Edwards RV pump. I know this will be a popular one. A lot of people got these pumps, especially I'm based in the UK, especially if you're over here because Edwards is a British company. These pumps are absolutely everywhere. So this particular one is seized. So we're going to have a little can I get it to work again kind of adventure here. It's absolutely filthy. It's been in the back of a workshop for many years, and just dragged it back out from storage to find out whether we can do anything with it. Interesting fact for those of you who are very old like me, this label up on here, Ultimate Vacuum Limited, that's a company that I started back in the late 90s. What does that make it? 90. You work it out. It's a long time ago, when I was a sprightly youngster. This company eventually became Ilmvac UK, which then became part of Gardner Denver, married up with Welsh. All the years that have rolled by. Anyway, I am gloved up for this video. I don't generally, but this one I think might be a little bit nasty inside. Let's get rid of some of this filth off the top here. Last round. Not much point cleaning the bench at this stage. I think it's going to get a lot worse before it gets better. So, how to tackle an Edwards RV. I've drained the oil out of this pump already. What little there was in there. As I say, this one's seized. It won't turn at all. So we're going to find out why and find out what can be done about it. There are two types of motors found on Edwards RVs. This is the older style, which has covers over the top bolts. So the first thing we've got to do is take the top cover off. I'll drop in a comparison video showing you a later type of motor which doesn't require this step. So with this old style motor, got to take the bolts out of the top. There's one missing just here. This is quite common. These motor covers are plastic, they get brittle, and then when you tighten or remove the bolts, they have a habit of cracking these posts off. This one looks okay. This is only cracked through the top. In fact, it hasn't even done that. Looking more carefully, it's just a missing bolt. But it's common for these posts to crack off and disappear, meaning that often these motors are only held on by the front two bolts on the cover. So having done that, our goal is to get this motor removed. Start down the bottom. Get the two lower bolts out. And the upper two, the reason I'm using this ball-ended Allen key is because these are going at a slightly funny angle. Just see that motor move. That's a great sign. That means that the motor's going to come off without too much of a fight. So with those 4 bolts out of the way, and look at that, off easily. So there's the first thing. I've got a seized pump that won't turn, but the motor turns fine. Sometimes the motors can lock up. It's quite unusual to have a locked up motor, but then I've now got access to the rear of the coupling on the pump, and that is locked solid. So the lock-up is actually inside the pump. Right, next thing I want to get this base plate out of the way. So again, it's 5mm again, the same as before, but this is straight, so we're using straight-ended Allen key. In theory, you can service an RV pump with 3mm Allen key and a 5mm Allen key. That's something to pull the seals out. I suspect we may need a few more tools on this one. That's the base plate off, placed to one side, which is filthy. Now, this particular pump that I've got here, it's an RV3, which is the smallest of the range. This one is actually what's called an E-Lab pump. I don't know if they still do these, but I do remember them well from when they were current. It's called an E-Lab pump. It has these fancy side panels that tell you when to change your oil. Starts off clean. When it's brown, change it. When it's black, lose all hope. On a regular RV, on this side of the pump, there is a control here, a rotary knob that controls oil flow inside the pump. On the E-Labs, it was a kind of a budget entry level model, so that was done away with. Keep it simple, but I'll let you into a little secret. If you take the side panel off, the control was still there. All they did was cover it up. Cover it up, sell the pump a little bit cheaper, tell you that it wasn't there. It's not uncommon. It's not uncommon. I think car manufacturers use the same technique. You know, all the gears there in the car for a certain function, I don't know, a heated seat or something. It's cheaper for them to make all the seats the same and all the wiring looms the same, and then just take the switch off the dashboard and tell you haven't got it. So there we go. That's the side flashes out of the way. Various ways to go about this at this point with an RV. You can go straight in, take the oil box off into the pump that way, which is how you would tackle most pumps. On here though, on the adapter, we do have a removable top panel, which I'll take off now. The gas ballast control, it's a bayonet fitting, so that's your 1 and 2 positions and your off position. If you push down on that against the spring, you can go all the way around past the 2 position, and that releases the bayonet. Those 2 lugs there, we can take that off, and can then tackle 4 bolts off the top. And then the top plate lifts off, Looks quite clean underneath there, doesn't look too bad. There's a gasket underneath there, which we'll get out of the way. I'll put it there. And then that's the spring that the cast ballast knob sits against. Underneath that there's a nylon, I guess you call it a shouldered washer. It's just a seat for the spring that sits over there. And then this is the inlet valve. The inlet valve on RVs is one of the things that can be a little bit temperamental. The idea of it is that it sits underneath the inlet of the pump. There's a spring underneath it. When the pump starts running, oil pressure will be forced up, push that down against the spring, opening the inlet and allowing gas flow through here into the pump via this channel. When the oil pressure stops, the spring will push this back up and it seats up underneath there against the inlet, stops any oil being sucked back. It gives you a partial retained vacuum, not full vacuum. Underneath is a spring, come out for now, and that is our inlet valve assembly. I'll go ahead and take this apart and show you what's there. The top pad just pops off, the ball on there, and then the plunger is then able to pop straight out of the bottom. Down here, this green part is called a U-seal. That is critical to the operation. When that oil pressure comes in, it fills up this U-seal and then pushes it down, and that's what creates the opening effect of the valve. And then the valve body, there's a couple of O-rings on here that will get replaced, and that's not going to come out. Let me just grab a pick to lift that O-ring. So there's one there that seals the body against the adapter plate, and there's a second one here which seals against the channel down there. And then right in the centre here, I don't know if the camera will pick that up at this point, probably not, but there's a little green O-ring underneath here, and if you turn it over, in the bottom there is a bushing. That needs to come out. We need to replace that O-ring. Getting that out is a little bit tricky. The way I tend to do it is to take a small screwdriver. This has had the sharp edges ground off it, and then I need to get that to sit in there on top of the bushing. It's very handy having this bench because there's a big lip around this bench to catch oil, so I can place it against that. Put my screwdriver into place against that seal and bushing, and then give it a few taps and out it pops. Usually takes quite a bit more effort than that. Usually have to go around it quite a few times before that bushing will come out. So we're on a winner there, and then again with my pick I can get down there, take out the small O-ring. That's the body of the pump, and then the piston just has that U-seal on it, and carefully with the pick underneath that, and then once you've got completely underneath it, you can just lift that away, and that's the U-seal out, which again is going to get replaced. That's the inlet valve, and everything on the top plate is now out of the way. So we move now onto the oil box. Take the exhaust fitting off. And the two oil filler ports. Why are there two? I'm going purely by memory here. I did train with Edwards, but it was a heck of a long time ago. Mid-90s or something, when this pump was just coming to the market. And if I remember rightly, they were originally an oil return kit. So when you've got your mist filter and everything up there, it was an oil return kit that was destined to go through one of these ports. So they put two, so you have one for the oil return and one as a fill port. Don't think I've ever seen a pump that has an oil return going through there. It's always just two fill ports. Pop that up on end. Take the drain plug out of there at the same time. All of these fittings that I've just removed all have their own O-ring, so those will all get replaced. And we can take the 4 bolts out from the oil box. Get that removed. Oil box comes off. You usually have to do it. This again is coming off very easily. How can the pump be seized when everything comes apart so easily? So that's our oil box. We're going to come back to, there's a removable sight glass on here, which I'll come back to in a moment. Take the gasket out. These are printed gaskets, so this is what commonly happens. It's a plastic substrate with whatever material that is printed onto it, and it tends to delaminate. It won't cause a problem while it's in the pump, but it does mean that they fall apart. It's what you call a sacrificial gasket. It goes on once and never again. It's not entirely true. If you do have a problem with the pump and you've only just built it, you can usually reuse the gasket. So now what we can see is the cartridge of the pump and the adapter still joined together. I'm going to invert that. I would usually take the coupling off at this point, but given that it's C-solid and the bolt is at this angle behind the metalwork, it's not going to be possible. So the cartridge is held into the adapter by these 3 bolts. And once the adapter's been removed from it, I have free access again to get at the coupling. So those 3 come out. These should have, and indeed on this pump they do, spring washers on there. Those are often missing because they fall out during service and don't get replaced. Not hugely critical, but they should be there. And then it takes quite a bit of force, but that comes off there. Again, that is not bad at all. You do often have to resort to our friendly persuader to release those, but we've got that one off. So that's the adapter, which is a single casting. The one final thing that's on there is that side control that was covered up, and that, as is usual, is extremely tight in there, especially given it's never been opened, it's never been operated because it's covered up. If you do find this, there is what looks like a screwdriver slot in the middle. That will just break the thing apart. The best way to get at it is with some long pliers, or these are generally called water pump pliers. That will give you leverage without snapping it. So that can come out. Underneath there is an O-ring, and then normally I take back everything I said, because this fitting, while it is in there as a plug, it's inoperative. I've seen these with the regular fitting on there. I don't have one to hand at the moment, so we'll have to do another video at some point with a regular RV. This would normally have a protrusion on the end with an extra O-ring that operates in here, but in this case that is actually inoperative. Most of the E-labs I've taken apart have had just a regular plug in there, and you could use it as normal. Anyway, that's out of there. That connects back to these two channels here. Lets you control airflow. We've also got in here a restrictor for the gas ballast. We just want to ease that out. There we go. A couple of O-rings around that, which is what holds it tight into the adapter plate. That whole piece will be in the kit as a replacement part. We'll get that out of the way, and that's our adapter fully stripped. Back to the pump. So now I've got access to be able to take the coupling off, but I'm not going to in this instant because the pump is seized. I want to be able to, as I take it apart, if it isn't blindingly obvious why it's seized, it'll be useful to be able to turn it and see, yeah, that stage is moving, that one's not. So I'm going to leave that there for the moment. We've got another, this is called the adapter gasket. And then we have a couple of important items here. The green pad under here comes out with its spring. There's a spring underneath there. That's the gas ballast non-return. That just stops oil from going back up the gas ballast pathway. So that spring and pad will get replaced. On the other side, assembled in the opposite direction, again a spring, and then underneath there we have, this is what we call the dump valve. The dump valve regulates oil pressure. It's in two parts which don't want to come apart. There we go. You've got a very small, I'm wearing black gloves, that was clever, wasn't it? Try and find a cleanish bit of rag to put that on so you can see it better. That's the shuttle that fits inside, and that's the body of the valve. And again, if they're in good condition, they can be reused, it's not a problem. If you've got a comprehensive kit, it may well have those parts in as replaceables anyway. So that's those out at the end. And we've got a baffle there with a bolt, and then underneath there is the valve carrier. So that comes off there. That's a backing plate. And then the valve itself is here. It's steel, spring steel. Fits over those two. You have an interstage valve that releases any pressure difference between the two stages, and then your final vacuum valve. That again is a replaceable part, although once again this one's in good condition and those are very reusable. So that out of the way. This pump is going to want to roll away now because the cartridge is round. So if I stand it on the end, two bolts here. That will get us inside. Worth noting that many of the bolts in an RV pump are interchangeable. Like I said, they all use a 5mm Allen key other than the small ones on the side panels and the motor top. But also, if I go back to, this is one of our oil box bolts. It's actually the same as the internal bolts. These have gone black because of use, they've got oil ingrained in them. They're essentially the same bolt, so a lot of stuff is interchangeable. Likewise, smaller ones, these shorter ones which fit the base plate and the motor and the sight glass, they're also the same as the internal ones holding the valve on. So a lot of interchangeable parts, no problem swapping them around. I tend to keep 2 pots on the bench for an RV pump, one with the external bolts that are clean, can just be reused, one for the internal bolts that will need to be thoroughly cleaned down. Now we've released that, but it's not going to come off because we've got a seized pump. So into these, each of these sections has quite a big gap in between, big enough to get a screwdriver in and lever them apart. Carefully, you don't want to chip any material, although these are very robust. It's unlikely you would, but that's our end plate. Underneath the end plate is the oil pump. So in there is a rotor with a vane, and that's where the pump is seized because that vane doesn't want to come out of there. So that vane should be loose and should drop out. That could well be where we're stuck. And I can check that, because if that now rotates, then that would be it. But it doesn't. So we're stuck in more than one place. There's no additional bolts here. The outside bolts hold the first 2 sections that were removed here. So that's our oil pump. Oil is drawn up through the large hole at the bottom here, comes up into the pump, circulated around, pressurised and sent out. This is our second stage. There's a coupling between the second stage rotor and the oil pump rotor, little plastic coupling. Again, it's a replaceable part. And then we've got 2 vanes in there which are not keen to come out. The rotor will though. Okay, so I can lift the rotor out of there, and then the vanes will slide out. So 2 plastic vanes, the rotor, which looks in terrible condition. This should all be shiny, shiny steel. There's a lot of pitting and damage on there. So with that out of the way, okay, and now we're turning freely, which tells me that this stage is operable and that the problem is in there, so I'm obviously going to focus on that. Back up on end, there is a coupling down here which couples between the 2 rotors. It's tricky to get out at this point, but it's fine, it'll come out when the bolts are removed and the next stage comes off. So again, in those deep recesses over here and here are the next 2 bolts that we need to remove. Again, same as the ones before, interchangeable bolts. Don't need to be too concerned about keeping fittings with the individual stages. And this is very free, and I can feel it's just oil tension holding that together. So there we go. That's our second stator, end plate, centre bearing, call it what you will. this side's pretty good. That's the coupling, it goes between the two rotors. Slides on there and locks in there, and the same on this side. And then we get to see, that's how we like it to look. Shiny and clean. If only the rest of it were in that good condition. Again, those vanes are a little bit tight. So now I've got to there, I do need to take the coupling off the back. No grub screws here. This is a full-size real bolt. You don't need to take that all the way out. Just loosen it to take the grip off the shaft, and then that should just lift off, as it does. Now the rotor can actually come out. That's all that's holding it, so I'll pop that free. Again, 2 vanes in there, and that rotor, which looks in nice condition actually. And then the final parts we've got on here is the outer shaft seal carrier. This is the seal that stops the oil coming out of the pump, and this is the seal that hardens off and leaks, and 99 times out of 100, if you've got a leak from your oil pump, it's going to be from that seal, which is replaceable. Of course, I've got very little to grab hold of, having left this till so late in the dismantling process. There we go. One. Get a grip on it, obviously. Everything is oily. Okay, let's just tie that another way. One really doesn't want to let go. Okay, now this carrier will be stuck down fairly firmly, so alongside the bolt holes here, the through hole, there's a threaded part, so the bolt you've taken out can be threaded into there, and this is what we call a jacking point. So as you wind the bolt down in there, it presses against the metal behind it and forces the cover off from there. It's extremely handy. Find it on several different pumps, but when you do, make use of it, because it makes removing them far easier. Otherwise you'd be under here prying against this soft aluminium and damaging that. So under there, a very critical O-ring. This O-ring also prevents oil from escaping. If you leave that out, then you turn the pump on, everything works great, you go away, get a cup of tea, come back an hour later, the oil's all over the floor and the pump seized again. So don't forget that one. There's a gasket that seals between the seal carrier and the cartridge there. So that is close to being done. We've got 2 shaft seals to deal with now. So the outer shaft seal, which is in the carrier, you've got good access to this. Again, I've ground the end off this screwdriver, taking the sharp edges off it, and what I'm going to do to remove this is to slide the screwdriver in between the rubber seal and the carrier, and then gradually by twisting the screwdriver, moving it around a bit, little by little. That seal should start to come out of there. This one is not playing ball. Usually you can get in there and move that fairly easily. That one doesn't want to move, but you can see that it's recessed quite deeply into the carrier. So my next option, same screwdriver, bring in the big persuading hammer, just put that screwdriver onto the back of the seal, give it a tap, and nothing happened at all. I need to do that a few more times just to drive it down. I'm just going to put it onto another bench where it's a bit more solid. And there you go, a couple more taps, that's now moved. So I can now get the blade of the screwdriver in behind there and lever it out the rest of the way. That's the outer seal out. The carrier will be reused with a new seal. And now we need to go inside and take this inner shaft seal out of there. Now this is quite deeply recessed. I can't get my screwdriver in behind there. I can't go in from the other end because again it's very deeply recessed and behind the shelf there. The tool that I use for that is called a split collet bearing puller or seal puller. It looks like that, and when you wind these two pieces together it causes the bottom to open up, and the way it works is you put it down through the seal so it sits behind, then wind the two parts in so that it opens up behind the seal, and then there's a slide hammer that screws onto the top of that and enables you to pull it. Now they come in a whole variety of sizes. This one generally works. I just opened it up a little bit there so that it sits. You can feel it's I can feel anyway. It's now sat onto the metal behind the seal. Remember I said at the beginning that you only need a 3mm Allen key and a 5mm Allen key. I haven't counted, but if you want to, go back, count up how many tools I've used so far. It's never as simple as they say in the instructions. So, holding the lower part, turning the top, and I want to get that as tight as I can behind the seal. Once I've got hold of it, I can apply the slide hammer. And hopefully that's going to pull the seal out. So, a few taps to get it going, and then there it is. So that's where it's come from, that recess there. Again, that looks in really good condition. So we've got a half and half pump here. Half good, half terrible. Let's take the slide hammer off there. And that's the seal, so you get a good view here of what's happened. That's gone down through the seal. When I opened it up, it's opened out and grabbed onto the back of the seal, and then the slide hammer allows that to pull it all the way out. I'll stick that to one side. You have to unwind it to get the old seal back off, but we don't need to look at that just now. So that's all the interior components. The last thing in terms of stripping down, there's no fixed order in which to do these things. You have to use a little bit of logic, but back to the oil box and we'll just take a look at this sight glass. Sight glasses in pumps, every pump has one, but they do tend over time, despite being glass, they will get badly discoloured. Sometimes to the point where you can't actually see the oil through the sight glass. So it's very handy. On a pump like the RV, you can take the sight glass out. So those two bolts, you can take out the aluminium cover, and then there's our sight glass, and there's a big green O-ring underneath there, and we need to change the O-ring. This will be fairly well stuck down, so the way that I release it is there are flats on each corner. Put a pick or a small screwdriver underneath and gently working from all points, just gently pry that until it comes free. It is glass, you don't want it to break in your hand. You can buy the sight glasses if you do break one, but it's not part of the kit, so that needs to be cleaned up, and we'll go back in. Then our large O-ring just lifts out of there, and that's it. That is everything stripped down on our Edwards RV pump. So this will all go away for a good clean. That will take several hours to clean all these parts. The parts where the seize happened, where it locked up, are going to need obviously extra attention. I still haven't taken that vane out of the oil pump rotor. Yeah, it is going to move. Sometimes you get a lock up and it's totally dead and nothing can be done. But sometimes it's a build-up of material inside that's wedged one part. I would imagine what's happened with this was the pump was running, vacuum performance was poor, so they switched off the pump, got another one out of the cupboard, stuck this one away, but it was probably running at the time that it was switched off and put in the cupboard. But all the built-up contaminants inside the pump have gone solid over time, and the next time they tried it, it wouldn't start, would be my guess. So all these parts are going to need extra attention with cleaning up. But I'll do that off camera. The reason being, it takes a long time, and cleaning the pump is absolutely critical. If the pump's not clean, then basically you've wasted your time doing this. You still won't get good vacuum performance from a dirty pump. So a lot of attention needs to be paid. Lots of different tools come into play, all of which are very noisy. And unless you want to stare at the back of my head while I swear at inanimate objects for the next 3 hours, I suggest we take a break. I'll go and do it. When everything's clean, I'll come back and show you the reassembly. Okay, so all parts cleaned, paying particular attention to the components that I had seized, like this oil pump rotor. Still a little bit dubious about this, there is some pitting in there, but hey, this is the pump we've got, this is the pump we're going to build, and we'll find out whether it works later. So I have a full comprehensive manufacturer's kit of parts. This big green washer baffle gasket thingy goes with the motor, so that can go to one side. We're a long way from needing that yet. Now what I've done, you can probably see back here, I haven't thrown anything away. Everything that came out of the pump is still there in that pile. And you say, but Angus from LabVac, you must know how to put this back together again. And indeed I do, as you're hopefully going to see. But I'm doing this for your benefit more than for mine. So when you pull the pump apart, keep all of those parts. When it comes to the kits, you get bags and bags of bits. Every now and then, one of the bits that you thought was going to be in the kit isn't in the kit. And so if you've kept all the parts that came out of the pump, firstly you can compare sizes of O-rings, compare seals and so on. It helps as a guide to which parts from the kit go where in the pump. But also, if you do run up against a problem where something that you thought was in the kit is missing, you've got a chance to reuse the old one. If it's gone, it's gone. But let's just say our dump valve here was missing from the kit. Okay, I've still got the old one in the pile there. I can go and clean it up and see if it's good enough to reuse. And hopefully at the end of this we're going to be able to throw all of that lot away. We didn't need any of it, but you never know. So I've chucked all of that in a big pile, and we'll figure out as we go along what needs to go where. I didn't spot that anything was missing as I went through that. So the other thing that we're going to need for reassembling a pump is a good supply of fresh vacuum pump oil. My general advice on pump oil, you've got to use something that is specifically for vacuum pumps. But beyond that, they are much of a muchness. I use the same oil in every make of pump that I rebuild from any brand. Unless a customer specifically says, I want this or I want that, that's fine. But for general purpose, I use the same oil in everything. It is a 19 grade, it's called Supervac 19. And I'll use that in all of the pumps. The best thing you can do to keep your pump in good condition is change the oil. So rather than a very expensive oil that you change every 2 years, use a less expensive oil and change it every 3 months. You get all the contamination out of the pump when you do the oil change, and that way your pump will stay in better condition for a longer period. So I'm starting here with my adapter. I'll jump back and forward, but first thing I'm going to put in is this gas ballast restrictor. I'm going to lubricate the O-rings on there. Always lubricate seals before they go in. Helps them go in more easily, but more importantly, it stops them from kinking or bending as they go in. So that just pushes down 2 clicks for the 2 O-rings. That's in there, and I know it's there. It's an easy part to forget. I'm now going to build up the cartridge, and I'm going to use the adapter as a stand for doing that. The reason being, if I put that down on the bench and try and fit the rotor to it, obviously it's not going to work. But the adapter is a perfect stand. So I've not fitted anything else into the adapter. This is not a permanent fix. This is just somewhere for me to stand it while I build this up. First thing that's got to go into here is the inner shaft seal. So the kit comes with 2 shaft seals. Only one will fit, and it's the larger one. So the larger shaft seal goes in there. In terms of fitting shaft seals, I like to push it in by hand first. That's actually gone a long way in. They usually won't go as far as that. Then I will take a set of regular seal drivers. So I don't use press. I use this type of thing. You get various sizes in the kit. what I'll generally do is start with the large size that's completely oversized to the seal I'm fitting. But when you drive it down with that, the seal will hit the metal surfaces and it'll make sure that the seal is sitting exactly flat. This one has dropped in there quite nicely, so I can just go directly to the correct size. And then with a couple of solid taps, everything on the bench is going to go flying. But hey, that's video. So with a couple of solid taps on there, that sits the seal into place. Okay, I know that hasn't gone all the way in, I can see it, but the way that I check is to put the rotor into place. Okay, that's as far as the rotor will go, and these two surfaces should be matching. So, okay, the seal's not in, I need to go back. I'm going to put it on a more solid bit of bench just over here, because if the bench is bouncing, then the seal's not going to be driven in. Right, I think that's all the way down, so I'm going to carefully dry fit the rotor into there until it sits down. No, still not there. So that seal is still not sitting all the way down. See, it dropped in the first part very easily and then decided to be stubborn. So I'm going to check again. There we go. And now you can see where the rotor and the stator come together there. I've got a totally flat path, so the seal is in and it's in correctly. And I can just lightly turn that. I know that's in. So there you go, third time's the charm. Now, rotor goes in next and I need lubrication. So I'm going to dip my finger in the oil and just run it around there. I'm going to make sure there's plenty of lubrication on the lip of that shaft seal. Now I can take my rotor. So that shaft seal is sitting on this surface here. So again, plenty of lubrication on there. Plenty of lubrication on the rear, which is going to be a metal to metal contact. So with the oil in between. And then drop the rotor into place. Now one of the nice things about RV pumps is that you can fit the rotor and then put the blades in afterwards, because you've got this fully open slot for the blades to sit into. A lot of pumps you have to fit the vanes first, vanes, blades, same thing. Fit the vanes first with their springs and spring supports and so on, and then hold the whole thing together while you get it in. So the RV, very simple from that point of view. My vanes blades have all been cleaned up. I've honed the leading surface on there to make sure that there's no marks or scratches in them. And then these can be oiled, dropped into the slot. In terms of orientation, they do have these notches in the rear that go opposite to each other, and that's in. Then I can add more liberal lubrication across the top of that, which will work its way down between the vanes and the rotor, keeping everything good. And then I should be able to just turn that freely by hand. When I turn the pump by hand, I always turn it in the direction that it would turn when it's operating. Just good practice. If you turn them in reverse, some pumps don't mind at all. Some pumps you will have certain surfaces that will catch on the vanes, catch the moving parts, and can cause scratching and damage to the parts. that's all that goes in there. There's no springs in these pumps, and there's no spring supports and so on. There's also no O-rings between these mating surfaces in the cartridge. There's nothing else to fit there. So we move straight on to second component, which is our centre bearing. The rotor is moving inside here, surrounded by a film of oil that acts as a bearing, and our second stator all machined from one piece, along with both of our exhausting valves there. So that drops on there, so I can rotate this to roughly where it would sit, and then the bolts that lock these two together will go down into these deep recesses that they came from, and the threaded holes are here, so I'm going to roughly line those up when I drop this on. Then I can take two of the long bolts. These have been cleaned up, polished out. They're still dark in colour, but you can see that they were actually shiny steel at one point, but they're clean. That's the important thing. The important thing is that everything goes back together clean. There's one little bit of contamination left in there somewhere, because it means that you're taking the whole thing apart again a day later. So just edge that round until the two bolts sit up straight, wind them down, knit them up. They don't need to be massively tight. You certainly don't need ratchets and extensions and things like that. I only use hand tools for dismantling and reassembly. The reason being that in a lot of cases you've got stainless steel fasteners going into aluminium threads, and it's very, very easy if they're slightly cockeyed that you just tear the threads out of the aluminium and ruin a good part, which can be very, very expensive to replace. So there we go, that's the first stage. We essentially do the same thing. We've got that coupling piece which has to go in now before the second rotor. So drop that down, obviously lining up the notches. You can turn it just to get it into place once it's in. That drops in there, and then our second rotor can go in. Again, big slot for the vanes, so we don't need to worry about those at this point. What we do need though, again, is plenty of lubrication. So I'm just going to dunk that in there, drop it into place, rotate it until it drops into the coupling, and then again, just a turn, just to make sure, yeah, nothing's locked up there. Back to my little pot of vanes, and again, these have been prepped and checked. So with some oil, it should drop into place. Okay, now we're getting to the parts that were seized previously, so it's all the more important now to make sure that that turns freely by hand. You can of course go to the shaft, which is protruding from the back here. If you're not able to turn that by hand, you can. It's easier. There are two little notches on here that I've just used, but my finger hurts now, so your choice. That's everything that goes in there. Again, no O-rings to worry about, nothing like that. Now the oil pump section goes on next. Again, we've got two through holes for the bolts that are going to hold that, and two threaded holes. It's not possible to put these things with an RV, at least. It's not really possible to go wrong in terms of assembly. What I will do is make sure that I've got plenty of oil on those surfaces and up the shaft bore, and then drop that on there. Now at this point I can't drive these bolts home because the bolt holds the outside cover as well, but what I can do is just just take a little couple of turns on there and make sure that it's located in the right position. So we now come back to our kit, because there was a little plastic coupler that went between the second rotor and the oil rotor, which is this piece. So this is a new one from the kit. Again, oil. These are a little trickier. Small parts are always harder to handle than larger parts, so you do need to get this to go into the bore flat to begin with, because if it does go off to the side, it can be very tricky to get it out and realign it. But again, once it's in there, you can just rotate it until it drops onto the lobes on the lower part, and then there are corresponding lobes here on the oil rotor, which is what goes in next. So again, drop that in. Now, this is one of the parts that was badly contaminated and seized. So I'm checking always at this stage just to make sure, yeah, it's in there. There is some play, but there always will be. But it doesn't seem too dramatic. And then most importantly is our oil pump vane. Still good. So that needs to sit in there. It's gone in nicely. And then what I want to do is just move it forward and backwards. There's going to be a very small amount of play, but if that's very worn and it's able to slide a long way backwards and forwards, it would have to be replaced. In this instant, I think we'll get away with it. Proof's going to be when the pump goes on test. So that's our oil pump built. So all that remains of the cartridge is the end cover. The bolts clearly are offset, so again it can only go on in one direction, and those need to line up over there. Okay, so again, lubricate. Put the cover on, and now these two bolts can drop in, and again, just by hand, make sure that they're aligned and that they run in smoothly. If at any point you get a fastener going in that's binding or that's difficult to tighten, stop, go back and recheck that the threads are clear, that you haven't got any debris in there, that they're not chewed up, because you can see how easily these should wind in. They're just spinning, and then knit them up. That's the major components of the cartridge rebuilt. So what I want to do at this stage is take the cartridge back out of the carrier, and I want to turn it and make sure that, again, everything is smooth. Now, actually in this instant I can turn that by hand. Usually at this stage of this many components you can't, so you can just slide the coupling onto the end of the shaft and use the coupling to turn it. What we should see at this point is some of that lubricating oil should be popping up out of the valves, like that. And I'm checking that it rotates smoothly, that there isn't a position where it starts to bind and you have to push past it. It should be smooth all the way around the rotation. So that's good. So far, so good. To complete the cartridge then we need a new valve from the kit. It sits in there. The retainer drops over the top, and then the bolt goes through there. You've just got to feel for it. There it is. Wind that down and snug it. Now we've got under there our valves assembled all correctly, and the baffle sits over the top with the other screw, which locates into there, Again, wind it down, snug it off. Now with the valves in place, we start to get all those lovely gurgly noises. It tells us that the pump is actually operating and opening the valves. So we're good at this point. So now we can turn our attention, quick wipe up, to installing the rest of the parts that go onto the end here. Now I'm going to start by fitting the outer shaft seal. Just make sure that just take any oil that's on there. And then our printed gasket that goes there. These are wonderful, they have writing on them. They do have to go a certain way up, but basically if you can read the writing, that's the correct way up. So that goes on there, 2 holes clearance. And now we can prepare and install the outer shaft seal. So it sits in this carrier. Also in the kit you have this washer, spacer. It's about 3mm thick, looking at it. So you have a choice now. My shaft here is in good condition. There's no grooves or damage, but if the pump's been running for a long time and the shaft seal's dried out, it can leave a groove in the collar on the shaft. So the purpose of the spacer is you put it in underneath before you install the shaft seal, and it moves the shaft seal by that 2 or 3mm along the sleeve on the shaft, so it's working in a different area and avoids the groove from the previous one. So I'll sit that in there, put my shaft seal onto there. Now with this one we're working on the inside surface, so there's very little for you to fit your tool against there, and you mustn't put anything onto the centre lip, because this lip is what does the sealing. If that gets damaged in the process of installing this to the carrier, then the shaft seal just won't function. It's got to be a little bit more careful with this one. Still the same process. Choose a tool that will sit over it and bring it down flush so that it's driving in straight. Again, this one has fallen in there nicely and is sitting flush with the metalwork of the carrier. So I'll then switch over to a smaller tool that is just the right size, and it has to sit on that solid outer of the shaft seal while you're driving it. So as with this one, it may well mean that you actually need to move this around as you drive it down to make sure that it sits in properly without getting any damage to it. So I was tapping on that rather than wellying on it, and you can see now that it's sat down there. And if I flip it over and check it from the other side, looking for any gaps, then that's all good, no gaps there. And then if you give it a shake, if the shaft seal's loose, then that spacer will be rattling inside there. So that's good, that's ready to go back on. Keep moving this sight glass around and do something with that in a moment. So I've got my 2 bolts ready to install the shaft seal carrier into place. And lubricate again the lip so that it will slide onto the shaft easily. There is a chamfered edge on the end of this sleeve, so it should go on nicely. But what I like to do at this point is just wriggle and rock it around until I can see and feel that it's popped on, and then drop the 2 screws in. Again, just start them off by hand, make sure they're going in smoothly, and then I can just push the seal down into place. There we go. Took a couple of goes again, but there we are. That's sat down. And then 2 bolts are down. Now these ones do need to be a little bit tighter. I'm not going to worry too much now. I'll show you a point at which I do that when I assemble the adapter onto it. But they're on, it's straight, it's sitting down flush all the way round. And then I'm actually struggling, I'll admit, to get a really good view of that. I normally have more light on the bench, but it does mess up with the camera, so I'm just going to bring a light in there, check all the way round, and check that that seal is seated nicely. If the lip gets caught going down on there, you'll actually see the lip poking back up, so we don't want that. Now, I mentioned this O-ring when I dismantled the pump. Really important, really important to install this now. This O-ring sits just behind that carrier. You've created a groove around here where the 2 parts come together for this to sit in. Don't forget that one. I'm just going to run an oily finger around there so that it's ready when we come to install it. Then we've got dump valve, gas ballast non-return, both of which use these springs, which are invariably stuck together in the kit. So the one over here is for our gas ballast, again a new pad, that sits there. When there's gas ballast coming into the pump, the air will push the valve away from the seat. As soon as you turn off the control, the spring will pop it back up, stop oil from going the other way. And now the dump valve. The dump valve is very critical. One of the problems that often comes up with RV pumps is that the inlet valve doesn't operate correctly. Sometimes it's down to the fact that the dump valve is not allowing pressure to build up sufficiently to hold the inlet valve open. So I've cleaned very carefully in here. I've made sure that that's clean in there. I've got my new dump valve and I'm just going to seat it at the top and watch it drop down by itself. So I know that's free to move in both directions. If it sticks, if it won't go in, if you have to push it in with some force, stop, take it out, clean again, because the pump won't work without that. The little shuttle drops face down into there, and then the spring will sit over the back of it. Okay, so that drops in, the spring goes in on top, and that's all those components in place. Got another printed gasket, goes around here. This can only go on one way, just follow the holes. All the holes need to line up with something, and when they do, it's in the right place. So that will sit down there, and then I've got 3 threaded holes visible here. It's time to fit the adapter onto there. So the adapter's going to drop in this direction. Lining it up is a bit tricky. I won't lie to you. So I've got my 3 bolts ready. A couple of ways to do it. You can drop the bolt in and use that to align it. The problem with that is you can't actually see the bottom of the bolt past the carrier. So pretty much the best you can do, and forgive the back of my head appearing in shot, but I need to look over there so I can eyeball it as it goes down. Line it up beforehand, drop it on. It won't drop all the way down because that O-ring that we fitted around here is going to be very tight in the body. It's going to need some force to get it down. But what I want to do at this stage is drop my 3 bolts in. Excuse me. And hopefully they're lined up correctly and will start to bite into the threads. But they're not. And that's usual. It's usual to miss. So I'm going to gently turn that until, did you see the bolts drop down then? They drop into their holes. And you've got to do that without the gasket moving, but typically it's not too difficult to get it lined up. And if the gasket has moved, you wouldn't get all 3 bolts through anyway. And then bit by bit I'm working around. You don't want to tighten one down all the way and then go back for the others, because the thing will never sit flat if you do that. So a few turns on each screw, winding it down all the way. It's pulling that O-ring into the body of the adapter, and then go around there and make sure they're all tight down. And this is the point where I'll go back to my shaft seal carrier bolts and just nip those up and make sure they're tight, because now instead of having to hold the round body of the cartridge, I've got something to get a hold of. Just make sure that those are tight down like that. Any assembly oil that's come out there we just want to try and get rid of. And then the coupling can go on for the last time. The shaft, hopefully you can see there, the shaft has a flat on it, and the bolt through the coupling needs to run along there. If it does go one way or the other, you can catch the bolt and start to cause difficulties. Now, I didn't line it up in advance, I can't get a tool in there, so I've just got to turn it a bit until I can. But then because the coupling's loose, I then want to check again that I'm not going to bind the threads of the bolt onto the shaft. And once I'm happy with that, nip that up tight, give it a turn, all sounds good, and we can move on. You can go one of 2 ways now. You can either do the top plate at this stage or you put the oil box on. I'm going to go oil box first. I don't always do it like that. What keeps my day interesting is sometimes doing the top plate first. You know, you've got to vary things. Again, take off any excess oil that's there. Grab the gasket. And on this gasket, they've actually written top there, so I know it goes that way up. Line it up with the 4 threaded holes, and then I'm ready to put the oil box onto there. So the oil box again is all sparkly clean now. For the oil box, I do like to put 2 bolts in the bottom 2 bolts, and I'm going to hunker down and watch those bolts go in. These do sit proud, so I can lower the oil box down, watch the bolts, see that they're in line, drop it down there, and then I should have good alignment. I'm going to start those 2, not driving them all the way home, just get them started. So you give it a little wiggle, make sure that they've run in smoothly and aren't binding. Because on these ones you are putting stainless steel bolts into aluminium threads in the adapter, and it's fairly easy to strip those threads out, and then it's a very, very expensive either repair or more likely replacement part. So a little bit of caution goes a long way. And again, I'm just doing these bit by bit, moving around the pump to make sure that all the surfaces come together flat and that I don't kink up the gasket. Nothing needs to be incredibly tight. Nothing needs to be incredibly tight on these pumps. There we go. Oil box is on. While it's in this orientation, let's finish off installing the parts that go on the oil box. I have a replacement O-ring for the sight glass, so you just got to pull that out until it fits the shape, drops in there. My clean sight glass sits on top of that. Then cover will go on. There's always one part you forget to clean. Quick pass of spray clean, just to make sure that's good enough to go back on. I don't show the whole cleaning process. I guess this one took me a couple of hours to run through all the parts from the pump and get them all up to standard. That's why I don't show it, because it is a couple of hours work. I guess at some stage, just lower those bolts in, I guess at some stage I'll make a video showing cleaning processes. I think rather than doing a complete clean on one pump, just run through some of the processes and tools that I use, because cleaning is entirely down to doing what the part needs. You want to get it as clean as possible with as little surface modification as possible. That's the mantra. You don't want to polish something until it's a different shape and doesn't fit back together and seal up tight. But at the same time, if you don't clean sufficiently, then any contamination left in the pump is just going to spoil the vacuum performance that you get at the end. That's my sight glass put back in. I've also got a drain plug. There's a couple of O-rings in the kit that are very similar in size but not identical, and one of them fits the drain plug and one of them doesn't. So one is going to be tight and pop back off like that. If you find that your O-ring goes on and then pops back, it's the wrong one. Throw it back in the kit and find the one that does stay, and then don't drop it on the floor. Okay, so that'll fit on there. Wind that down. I can wind that up tight, so it won't need to come out again for now. But again, finger tight. Do not put a tool on here. Don't grab it with pliers and tighten it down. It doesn't need it. If it's leaking because the seal's not working, not because you haven't done it up tight enough. That's everything on this surface. Turn the pump around and I can refit. Typically with Edwards, the seals that go on these, the O-rings that go on these are green. In Edwards language that means Viton, but in fact pretty much all of the O-rings in this kit are Viton. Most of them are black. Viton comes in any colour. Green does not indicate Viton, it's just Edwards that do it that way. So those two can go in. And the exhaust. Now this exhaust is not from this pump. These pumps would typically have a grey plastic KF25 flange fitted on here. But all of these use the same 3/4 BSP parallel thread. So they're interchangeable. This is from an older EM pump, but a lot of labs use tubing and not KF flanges. So this has just been swapped out. Rather than having to have an extra fitting and an extra seal and clamp to convert it into a tube fitting, you can just unscrew the original and fit that in its place. Again, finger tight, that's all it needs. Okay, back to the adapter. There's a couple of things to do here. One is to refit the plug in here. If it had the full control on there, that small green O-ring would fit onto the nose and adjust the flow through here. But we don't have that part, we have this part, so this just needs to have an outer O-ring fitted on there, which just seals the plug against that. Wind that down, and that can go all the way tight. That's done. Now we come to the inlet valve assembly and the top plate. So I'm going to move this to one side briefly and look at the components of the inlet valve. So that's the body, that's the piston, that's the bushing that we took out, and somewhere in the kit I have the replacement parts for that. Sorry, I picked up the wrong O-ring at the time. The larger one of those is for the nose of the oil flow control. The smaller one goes into here. So the small one has to drop into there, drops down into the centre, and it needs to be sitting flat. So give it a tap, poke it with a stick, whatever you need to do to get it to sit down flat in there, and then the bushing will go in on top of it. When you've got big hands like me, fitting them into this small space is a little bit tricky. So again, get the bushing so that it's sitting flat. You can push it part of the way in, usually, if you can on here. So that's in, but it's not tight on that O-ring. If it's not tight on the O-ring, then the O-ring won't be tight on the shaft of the piston, and you get leakage past it. So this actually needs to be tapped into place with a very small seal driver, which sits just on top of there. Now you want to be careful doing this. If you hit it hard, put a lot of pressure on it, that metal bushing is going to go straight through the plastic and leave you with a big hole there. Whole lot goes in the bin. So this is real gentle tapping here to sit that down onto the O-ring. Okay, and then what I'm going to do, I'm going to put a little bit of oil onto the shaft of this piston, and then this is reversed. It would go in that way normally, but it's easier to feel the tension, put it in this way. Okay, and I can feel now that I've got resistance to the movement there, which means I've got a proper seal. The inlet valve is often a problem on these pumps, as I've already said. If the oil pressure isn't right, or if the assembly of this isn't correct, then what will happen when you start the pump is this will open, vacuum will be great, half an hour later the vacuum will spoil and you'll lose vacuum from the pump. And what's actually happened is, because of the combination of those conditions and the reduced viscosity of the oil, so the oil is thin because it's hot, it's not exerting enough pressure to hold the valve open, and the spring will just push the valve back up. So the pump is running fine and making great vacuum, but your process that's attached to it isn't seeing that because the inlet valve is closed. So it pays to put a bit of attention in at this stage to making sure this all goes together correctly. So on the bottom of this piston, that's alright, it's clean. It goes how used to, it goes that way up. Oil pressure is going to push it down. So that sits in there, and make sure that that lip tucks all the way under. Then what I'm going to do is dunk that in the oil, fill the lip seal, and push it home into the valve. And then the green pad sits on top of there. You can actually leave it on the bench, push down, piston's going to drop, till it hits the bench, and then that just pushes on. And the assembly is there, and there's a couple of O-rings that need to go onto there, one of which sits around the outside, seals the body against this lip in the pump. There's a second one that rolls down there and sits into the groove provided, and obviously that is going to seal then into the body there. So with those two seals in place, I'm going to lubricate both of those so that they'll sit home nicely. And then the whole valve body can be lowered in, not forgetting to put the spring in underneath. There's a seat cast into the bottom there that the spring sits on, and then the inlet valve pushes down into place, and it should go home firmly when those O-rings grip in. The other part that we want to put in at this stage is we've got a new spring seat for the gas ballast spring, sits in there, and then one of our printed gaskets, which again is clearly marked and can only fit one way round, so if the writing is facing you, then you've got it correctly. And at this stage the top plate can go back on, so that's just lowered over there. Grab 4 short screws, they go in there, and you've got the spring under the valve pushing up, so you need to press down against that spring. Wind those 4 valves in. Again, stainless steel fasteners going into aluminium threads, so caution to make sure they're lined up correctly, and then tighten off. Then our gas ballast control needs to be refitted, so there is buried down there a spring which just drops in there and will engage onto that seat. And the gas ballast control knob itself, again there's a couple of O-rings that need to go onto that. They need to clear the 2 lobes on the top. One sits there and one sits all the way over. Now that one that goes all the way over doesn't tend to engage very well and falls out. So the alternative way is to place it onto the opposite face that it's going to seal on, and then the 2 lobes on there need to align with the 2 slots. And again, it's a bayonet fitting, so push it down against the spring and turn, and that's the gas ballast refitted. Quick wipe of the bench, some stray assembly oil on there. So the pump is now back together, everything's fitted back in. Quick check of the parts that are left over. This green flap, I mentioned that this is the not incorrect, alternative, shall we say, fitting for the exhaust. The original exhaust fitting, which is a flange, this is a baffle, a noise reduction baffle that sits in the top of there, so we can't fit that. The coupling rubber is going to go in shortly, and then we have a couple of redundant O-rings. The sleeve on the main shaft where the 2 oil seals fit is actually a replaceable sleeve. It's unusual that it needs to be replaced, but if it does have deep grooves cut by old seals that have hardened off, then it can be tapped out of place and a new sleeve fitted, and there's an O-ring to suit that fitment if it needs to be done. Like I say, given that you have that spacer washer in the outer shaft seal that can reposition it, it's unusual that that needs to be replaced. So we tip the pump up on end because it's time to get the motor back on. On these pumps there's no felt pad. Hooray! I'm not a fan of the felt pad fitted to a lot of pumps, which is essentially there just to delay the time between when the pump starts to leak and when you notice that it's leaking. I would prefer that when the pump needs servicing because it's leaking, you get on and get it serviced. So I like RVs because they just don't have a felt pad in there. So the rubber element fits tight into there. Then what I do is give that a turn until I've got the open notch facing the top of the pump. Just helps with alignment so I can see or know where the motor should be fitting. Now on these pumps, on the smaller, the RV3, RV5, you have a handle that fits in here. It was missing from this pump when we took it apart. But from my box of tricks, I found a replacement handle. And that needs to go in now because it's impossible to fit once the motor is on. So if you forget it at this point, then leave it forgotten. But that's where the handle should sit. The larger pumps don't have a handle because they're deemed to be overweight for lifting by hand. So they have a lifting eye plate. So your RV12, should you have one, should only be lifted via the lifting plate. Of course, that's not what we do in the real world, but there we go. So the handle sits in there, and then the motor is going to sit on top. Let me fetch over the motor. Here's our motor for the pump. I haven't run this pump motor yet. Normally I would do that off pump before I assemble it, but I'm going to take a chance on this one. Now, the large green gasket from the kit, this is where it comes into play. So it sits there on the pump, but it needs to be fitted to the motor in advance because it sits behind the fan on the motor. So you've got to take this fan off. Again, this was missing from this pump. I took it apart, and to be honest, a lot of people don't bother to refit this. Essentially it's called a ducting gasket. Again, it's to do with airflow. It's mostly for noise reduction rather than anything else. So I've undone the pinch bolt in there, and then I can lift the coupling carefully. It's an aluminium casting, so you don't want to be putting too much force into it, cracking the aluminium, but it should just lift off there. And then if I flip it over, you can see that pinch bolt that I undid underneath. So with that out of the way, we can take the green gasket, put it onto the pump. It doesn't matter which way round it goes, doesn't make any difference. So that's going to sit there. It's going to fall about and flop around once the coupling's back on, but check that it aligns before you start. And then there's a flat on this shaft, and the pinch bolt needs to clear that, same as it did with the other side of the coupling over here. So I'm just eyeballing that to make sure it's in the right position, and then I can push that back down. They usually get pretty tight, which this one is, so I'm going to go back to my seal drivers. The correct position for this is with the shaft flush to the top surface. So that one is too big. There's one that sits in the middle. So what will happen is, as this comes down, the seal driver should stop when it hits the shaft, so we should automatically get it into the right position. There we go. So that's just proud, but seems to be happy at that. It's turning freely. Then I need to slide the Allen key underneath the green gasket and just pinch that bolt back up. So that's fitted. Now we can flip the motor over and put it onto the pump. So I've set this so I know that I need a notch at the top. So again, I can then set that so that they align. The motor's heavy, it's immediately gone out of alignment. This is what you're battling with. So you've got to keep this gasket in place. What I do is tip that onto the end, the gasket will fall away. Take a couple of bolts and just slide the bolts through and through the gasket. So that's got that roughly aligned. Then I want to pick the motor up in such a way that I've got finger control of the position of the coupling, and it should in theory then, with a little bit of wriggling and jiggling, drop down. This has done what they always do. It's not sat down properly into the coupling. With the RV, you can actually look through from the side, either side, and you can eyeball that coupling. And then what I'll do is just take a pick, look for the spots where the rubber hasn't completely engaged properly. I'm just lifting that, and then I can turn it by the fan and see which lobes are engaged and which ones aren't, and then with the pick I can just slide in there and separate the lobes, push around on any that don't line up. So I'm happy that it's going in correctly. What you don't want to do is pinch one of the lobes of the rubber. It'll work, but it'll deteriorate much more quickly if that happens. Okay, so that's all lined up and it's starting to sit down. So I'll drop the last two bolts through. Spin those in. And they'll just pull everything down. And then I'll just switch to the ball-ended Allen key to get access to the top two, which should spin freely in like that. Shouldn't need any force to be applied to get those working down. So motor attached. Base plate goes on next. It's been cleaned, but I'm going to give it a final wipe down. These can be really grungy if the pump has been leaking. You'll get oil, and then the oil will pick up dust from the environment, and they can end up pretty nasty. This one's good. That attaches back onto the pump. With another 4 of those shorter M6 bolts. Number of bolts left in the pot is going down, which is good. Try not to have anything left over that I can't explain. There we go, base plate's on. Motor can go back the right way up. The cover drops on there. And then those screws need to go in. The 3mm key. This one is obviously tight on the plastic, so it's just going to have to be convinced. There we go. That's winding back in now. So the motor cover goes on all the way around. Really don't apply any sort of torque pressure onto these. I mentioned that they do have a habit of snapping fairly easily. Then the side flashes go on, of which there are 2, but they're not identical. The positioning of the holes is different, so they will only go on one side. And I'll wind them in. I'll finish off those last few screws and then move the pump over onto the test bench where we can see what kind of figures we get from it. Now, as luck would have it, while I've been working on the RV3, this RV12 has turned up for service, which gives me the opportunity to show you a few little subtle differences. Up here we have no handle. This has got the lifting eye that I mentioned. I'll give it a tilt, you can see the lifting eye on there. So you can hook into that and use a winch to lift this pump, which I've never done, but you can. This is the newer style motor, which has these cutouts here that allow you to get your tool into the top bolts to remove the motor without having to take the top cover off it. And then I'm just going to whip the side flash off here. There it goes. And then you can see on this one you have this large cutout that covers over the oil flow control valve, which is down here. So I'm just going to whip that out and show you the difference between that and the it's actually free, that one. This looks like a very new pump. Take that out. I did check that there wasn't any oil in there. So this is the long nosed version that I talked about earlier, just so you can see the difference. It has a pad on the end and it has that green O-ring that sits on the shoulder there. What that does, as you open it, it allows more oil to flow through the oil circuit. So it gives you some ability to control the flow of oil. If you had a very dirty application or if you were using the pump, it was originally intended as an option in place of having single stage versions of the pump. The previous EM range, for example, an Edwards 5 at the time would have been an E1 M5 or an E2 M5. The one had a single pumping stage, the two had a double stage. When they went over to the RV pumps, they did away with that. They only supplied two-stage pumps. And for those people who said, I wanted a single stage pump, I've got a rough application, I only need a single stage pump, this control is fitted to provide the option. You can open it up, more oil flows through the circuit. It makes it more tolerant because it's circulating more oil. So if you've got a nasty application, it becomes more tolerant by opening that control up. That's why it was provided, because they did away with the single stage pumps. I'm not aware that anybody ever really uses that control. A two-stage pump is better than a single-stage pump, isn't it? Bound to be. So it doesn't tend to get used, but that's what it looks like, and that's what the difference is there. So we're over at the test bench now with this RV3. It's up and running, it sounds good. Just to look at the vacuum at the moment, it's not quite there. It's low 10 to the minus 2 figures. We'd like to see that getting in 10 to the minus 3s. So I'm going to let it run for a good couple of hours, see where it gets to, and then decide if I want to go back in and do any rework. But it is still improving, and given that this was a completely seized pump that hadn't seen any use for many years, I think we're on the right track with this one. Thanks for watching.